tell us that the goal is to make this much money. That's their goal. Of course, they're okay with making more than that. If it just said we want to reach this much, it would be an equation. But because we're setting a goal and we're okay with making more than that, it's going to be an inequality, right? We're selling t-shirts and keychains. These are connected. Let's call X t-shirts and Y keychains. So if each t-shirt is $10, we're going to say 10X. We don't know how many t-shirts we're selling, right? They're $10 each. And $2 per Y per keychain. We don't know how many we have. And then, now we need to think about this inequality symbol. We know this is our goal. The inequality symbol can be tricky. The right side's our goal of $500. We're okay exceeding it. The left side is going to be money we're making. So let's think about this. The goal. The money we make, do we want the money we make to be more than, greater than our goal, or the money we make to be less than our goal? So read the wording behind the equation and then flow to the right-hand side and read that inequality symbol. If we said 10x plus 2y is greater than 500, we'd be saying the money we're making is greater or more than 500. If we had less than, we'd say the money we're making is less than 500. So for this problem, we're talking about making money and we're trying to hit a goal or exceed. So we're going to say greater than or equal to. So let's come over here. We have our x-axis, we have our y-axis. So we're going to graph and look at all of the possible combinations of t-shirts and keychains that we could sell in order to meet or exceed our goal. So there's lots of options, right? Lots of different combinations that would get us to our $500 goal or more. If someone bought 1,000 t-shirts, you would exceed your goal. If someone bought 10,000, you would exceed your goal, right? So there's lots of different options and combinations given the t-shirts and the keychains and their cost. When you have a real world problem, I think it's actually best to plot your x and y intercepts. So I'm going to find the x-intercept and I'm going to find my y-intercept. So I'm going to pretend that this said 10x plus 2y equals 500. 10x plus 2y equals 500. So to find my x-intercept, I'd put 0 in for y, and that's gone, and we divide by 10. So I know x equals 50. And over here, to find a y-intercept, I put 0 in for x, divide by coefficient of y. So y is 250. We know that x represents t-shirts, so I'm going to write t-shirts. We know that we said y represents keychains. I'm going to come over here and label this as well. So on the y-axis, we said keychains. X-axis, we said t-shirts. Now I'm going to rescale this because of my numbers. So if on the x-axis, if I have an x-intercept of 50, I don't want to count by ones. Maybe I'll count by tens. So this would be 10, 20, and I'm going to label it. Oops. 10, 20, 30, 40, 50, 60, 70, 80, 90, so on and so forth. So we're gonna scratch these, and we know we're counting by tens. So if the x-intercept is 50, I know I'm gonna do a closed circle because of this inequality on 50. And then my y-intercept is 250. So on the y-axis, I might count by 50s. So 50, 100, 150, 200, 250, 300, etc. So I'm going to do a dot here because of an inequality symbol. It's closed. Now, it's a real-world problem, so I have this line that goes like that, but I'm only going to keep it in the first quadrant. And it's a closed line because of the inequality symbol, meaning all ordered pairs on this line are solutions. I'm going to test 0, 0. So let's go to our inequality. Is 10 times 0 plus 2 times 0 greater or equal to 500? No. So that means don't shade. So don't shade. So we're going to shade the other side of this line. Now every ordered pair in this shaded region represents solutions. What that means is if we find an ordered pair in this region, for example, let's look at 50, 60, 70. Let's look at this one, this point. If we pick that ordered pair, 80, 250, this means something given the real world problem. This is saying if you buy 80x 80 t-shirts and 250y keychains, you are going to be in your beyond goal areas. So you'll be happy you've made more than $500. So in the shaded region, you've made more. You've made more than 500. All the ordered pairs on the line, you've hit exactly the $500 goal. Like the ordered pair 50, 0 is on the line. So this is saying if we sell 50x, 50 t-shirts, 50 times 10 is 500. If we sell exactly 50 t-shirts, we've met the goal. So all points on the line represent hitting your goal, hitting exactly 500, and everything else in the shaded region is exceeding, so more than $500. It could be $502, but everything in the shaded region is more than the $500. So there's lots of combinations of answers. Okay, write an inequality from the graph. So now we're going backwards. Before they gave us the equation, now we're going backwards. So I know, first of all, because the bound is closed, there's not a dotted line, we know it's going to be less than or equal to or greater than or equal to. Thing number one, I like to find my y-intercept and my slope. So the y-intercept is the first thing I look for. It touches the y-axis at -3. The scale is 1 unit, right? So the y-intercept is -3. The slope we know is positive because your line is rising. And it looks like it's up 1 over 1, up 1 over 1. So up 1 over 1 means it's a positive 1 as a slope. So we're going to get this set up. Y, if it's y equals mx plus b, we're going to replace the equals with an inequality symbol. We'll have y. In our slope spot, we'll have a positive 1. X, our y-intercept is -3. Now the tricky part is figuring out this inequality symbol. We know we have two options, less than or equal to, greater than or equal to, because it's a closed line. Well, let's see which one makes sense. If 0, 0 is shaded, if 0, 0 is shaded, then when we plug that in, we should get a true statement. If 0, 0 is shaded, when we plug the ordered pair in, we should have true statement. True statement. So which of these inequality symbols would create a true statement when we plug 0, 0 in? Now you can pick any ordered pair in the shaded region. So is it going to be y is less than or equal to 1x minus 3? Or is it going to be y is greater than or equal to 1x minus 3? Which of these symbols would represent the right shading? Well, let's see. Let's go to the top one. Let's plug 0 in for y and 0 in for x. So is 0 less than or equal to negative 3? Is it going to be 0 less than or equal to negative 3? That's the true statement. Or 0 greater or equal to 0 minus 3? 0 greater or equal to negative 3. Which of those is true? 0 is less than or equal to negative 3, or 0 is greater than? This is true, so we're going to go with this inequality symbol. Y is greater than or equal to 1x minus 3. Okay. Some more examples. So example 3. What inequality does each graph represent? So right here we see our dotted line, so we know it's going to have to be a less than or a greater than symbol. I want to find the y-intercept and the slope. The y-intercept is 0, 0. The slope is up 1. It's positive, right? Up 1 over 1, 2, 3. So it's going to be positive 1/3. So we know it's going to be y, 0. Oh, what am I doing? Y, not 0, our slope's 1/3. Y equals m x plus b. And then what symbol goes here? Is it going to be less than or greater than? So is it going to be this, or is it going to be this? Well, which of those makes a true statement? Now I'm going to erase the plus 0 because I don't write plus 0. Which of these is going to be true? It's going to be less than. If I test a point, let's say I test 2, -1. So 2, -1 should be true. So which of these, when I plug in 2, -1, would stay true? So is -1 less than 1/3 times 2? Yes, -1 is less than 2/3. So that makes sense. I picked the right one. Let's go to the next one. So I know it's going to be less than or equal to, greater than or equal to, because it's a full closed line. My y-intercept is 1. So my y-intercept is 1. My slope I know is negative. It's going down 1, down 2, right 1. So its slope is -2. So we have y is less than or equal to -2x plus 1. I thought about these symbols, and I know if 0, 0 is true. If I go with the less than or equal to, is 0 less than or equal to -2 times 0 plus 1? Yes. So I know it's the less than or equal to. Okay, last problem. Does the inequality represent what is shown in the graph below? So let's see. If we divide everything by 3, we would get y is greater or equal to 2/3 x minus 2/3. So it looks like they have a y-intercept at -2/3. It looks like they have a positive slope of 2 over 3. Let's see. Look at the inequality symbol. This shows us greater than or equal to, which would mean that we have a closed bound, closed line, full line. But this is a dotted. So no, this inequality does not represent the graph, because the bound or the line should be full, not